We are in Module 3 this week. In this week, we will talk about Chapter 3 and complete Chapter 3 to talk about x86 preprocessor architecture. So in this chapter, we will talk about a couple different sections. The first beginning, we will talk about the general concept about the preprocessor cycle, how we pass in the data and process in the CPU. We were using the Intel architecture 32 preprocessor example to demonstrate all the components from the Intel architecture 32 microcomputer. Of course, we will focus on 32-bit environment for this class. We also will talk about in 64-bit preprocessor. Then at the end, you will understand input and output system from the CPU point of view. I know the first beginning you will think about what is x86, or we say Intel architecture 32 preprocessor. So the first thing from this textbook, the textbook we use, we call that for x86 preprocessor. So if you try to Google the x86 preprocessor, so here I give you some Wikipedia example from the link. You can go over to that. So here, if we go over to see the x86 from the Wikipedia, you can see here x86 actually just a term to use to describe a CPU instruction set compatible with the Intel 8086. So that actually is a big whole family, start from 16-bit to 32-bit and 64-bit environment. So that CPU architecture using for a lot of desktop and laptop computer. The latest 30 years, you used any computer, no matter that's desktop or laptop. Of course, we didn't talk about the workstation like the Unix system. So just the personal desktop or laptop, all the CPU architecture is x86. So you see here, the longest time is from 1985. Even we just use the 16-bit environment, that's from the x86. And now no matter you use the Windows computer or Mac computer, you maybe have using the Intel CPU or AMD CPU. So that's all including in the x86. We start from 1985, we have the 16-bit environment. So then we go to the 32-bit environment. Even from 2004, we already have the 64-bit environment computing system. So before, definitely you will ask, what is 16-bit, what is 32-bit, what is 64-bit environment? So in this class, we will talk about that. But to be short, to tell you what is the 32-bit, what is the 64-bit environment, I know most of our computer now use the 64-bit. So those bits, no matter 2 byte, 4 byte, or 8 byte, they are matter to how to calculate the memory address. So on the other hand, in 80s, 2 byte memory is enough to calculate, 2 byte size is enough to calculate the memory address. Because you can see 16-bit is power to 2 to the 16 power. But 32-bit, you can up to 2 to the 32 power. So later we will calculate for you. Actually, that's why for the 32, you can calculate at the most 4 gigabytes in memory. So 4 gigabytes in memory actually is not enough because a lot of your computer already being, your RAM already being 16 gigabyte, or your hard drive is more than 1 terabyte. That's the reason we're moving forward to the 64-bit. So when we introduce the 64-bit environment, we will show you, right, 64-bit can allow much bigger memory calculating, but so far we didn't need to use that much yet. So that's we will stay in the 64-bit environment for a long while until we move to the next one. You will know that will be 128-bit. So if we want to know more, here has more information about the list for the x86 CPU. So not sure how you guys start using that. For mine, I remember possibly my first computer is i386 in 90. So that's 32-bit environment already. So now you can see here, afterward, right, we talk about Pentium. We talk about the dual Pentium. So then you have the cord. Most of us using the cords i3, i5, i7. Even some of you maybe have i9. That will be the 64-bit environment. So that's why you can see those bit environment or the x86. We are talking about the hardware. So that's why in chapter 3 or chapter 2, we will talk about a lot of hardware process. So if you want to have more information, let's go to see the x86 information online. So our example in chapter 2, we're using the Intel architecture 32-bit. So let's talk about the first thing. Let's talk about the general concept, how the microcomputer design, and how each instruction when we execute their cycle, how they look like. And of course, we need to process the instruction. We need to process the data. Data will reside in the memory. So we will see how reading the memory. So at the end, after you have the complete picture, we will really see when you run the program, what really happened in the hardware. First thing, let's see the basic microcomputer design. So we talk about the basic microcomputer design. We need to go to the hardware and to see how the CPU look like. So the CPU actually stands for the central processor unit. So they usually you only look like a square hardware. So here we're using a picture to show. But one thing is, if you try to Google the picture, we just said earlier, for example, we're using the Intel Core i5. I believe most of our computers are i5. You may have i3, i7, but that's the i5. So you can see here, when we talk about the hardware later we will introduce, we are talking about this small square. So this small square, actually that's the CPU reside in. So then here you see a lot of pin. But visually, that's what we can see. But later, of course, we will put that picture to graph that's in the picture to show you the memory and data flow. But that's the CPU we want to talk about. That's what we can see here. When we talk about the CPU, you will have your model number. You will talk about the gigahertz. So later we'll see this gigahertz actually just mean your processor speed. So that's what we'll talk about in your hardware. You may not see that until you open up your computer. So that's in the computer, actually everything processed in the CPU. CPU is, we say, the central processor unit. In this square, actually, we talk about that everything here is the CPU. But the CPU actually has a couple different parts. So the first one you can see here, we have the CU. That's what we call the most important thing is the control unit. So this control unit actually is coordinates the sequence of the execution step. So when you say about the sequence of execution step, that means is each instruction. So now you guys should be know about what is instruction. Instruction is earlier we showed you last week about the machine language or assembly language. You want to move a data to somewhere. That's just one instruction. So those instructions actually they will be line by line to wait there in the waiting queue. The control unit is the person like the police office to coordinate the sequence of the execution step. So they will tell which part they should start working and which part should wait or moving forward to the next step. So that's just the police to control everything. Then in the CPU, after besides the control unit, you have the other one called ALU. So ALU stands for the arithmetic logic unit. So you can see from this name, this central unit actually is perform the arithmetic and the bitwise processor. So the bitwise process, you can think about, we talk about in the memory, we have each byte contain 8 bits. So each bit processor, that's performed by the arithmetic logic unit. So they will really do the calculation. So that's why you can see here, besides these two, the police control to coordinate the sequence. ALU charge for the calculation, no matter that's logic or arithmetic. So then we have the next one is we call clock. So what is clock? Clock actually just means one clock time, we will only work on one instruction. So that's why the computer hardware follow the order. One instruction need to finish in one period of time. So that's the clock. So here in the CPU, they have these 3 parts. And later, did you see here? Did you remember in the chapter 1, we talk about EAX, EBX. I told you, just remember they are registers. Right, those registers, later we will show you. In the 32-bit environment, we have different registers. In 64-bit environment, we have similar but more registers. Those registers actually reside in the CPU. So that's why when we show you the machine language and assembly language, we work those data on the register. Why? Because they are right in the CPU, so they can direct access the data. So that's why they won't wasting time. But of course, in the CPU, those registers and the space is limited, right? Right. So we still can pass the data from the memory storage unit. So they can be RAM, they can be hardware, they can be hard drive, or any I/O device. You may have your the USB drive, okay? But those hardware device outside the CPU, if we want to read or write any information, we need to go through the data bus. So those data bus, you will passing the memory address. So the data goes to a data bus and passing the data into the CPU. So you can see, even you don't know how they process, right? Do you think you were using the data from register to process in the CPU is faster? Or you want to read the data from the memory address, then you put the value into the CPU to process? Yeah, definitely no. Any value inside the CPU, of course, they will process much faster. So then later we will show you how we will do that. So of course, in the CPU, we have the limited resource. So that's why CPU, all the time when we have multiple application or process running, we need to have the central control unit to do the traffic control to coordinate. So then if we can pass in the data, just process in the register, the speed will be much faster. Otherwise, that's fine. We just need to go through the control bus and the address bus to read the data from the memory address. So before I show you the whole picture, I just want to talk about the clock additional more before end of this video. So actually clock is the synchronize all the CPU and the bus operation. So we say clock is one period of time. In this period of time, only one operation can work. They can be in CPU or they are in the bus. So the bus is we talk about is the data bus or control bus. The only one action in one period of time. So how to calculate the clock time? So the clock time actually just a single period of time for one single operation. The duration of a clock cycle is calculated as the reciprocal of the clock speed. So that's why, did you remember the speed? Earlier we showed you. When we talk about the i5 processor, so you see here, remember they always told you, oh, you are 3.4 gigahertz. So this gigahertz actually is represent the speed of the clock. So 1 gigahertz is 10 to the 9th power. So then we were using this one to